We're going to move forward and bring on Bill Fredericks. Now, Bill has got amazing company, Advanced Aircraft Company, and we found him in the private equity sector. We're going to talk about the different types of drones that he works with. Bill, welcome to the show.
Hello, yes, thank you very much, and thank you for having me on the show.
My pleasure. Your background, aside from graduating from Purdue in 2006, but you've got a degree in aeronautical engineering. You joined NASA, Langley Research Center in 2003, and started as a co-op student working in aeronautic systems and an analysis branch. Embellish
Yes,
that
that's
for me.
correct. Yep, and also spent some time in the Marine Corps as an artillery officer and had an Afghanistan deployment in 2011.
How's the hearing?
It's not great. I normally have to have folks talk a little bit louder when I'm in a crowded space and stuff, but I don't have hearing aids or anything.
All right, now let's get into what you're talking about here. 80% of UAVs are multi-rotor and only 20% are fixed wing. So let's open it up to what does your company do, Advanced Aircraft Company, and then I'm going to get into some of these talking points that we have for today.
Yeah, wonderful. Well, actually, maybe let me first start with what's the big value proposition, what's the market segment, what's the problem we solve.
Okay.
And the value proposition today let me first say the problem today is that UAS operators suffer from poor utilization. So we're an aircraft manufacturer. Our customer would be the operator. To use an analogy, we'd be like Boeing. Our customer would be like American Airlines. Similar analogy, but for the unmanned aircraft space. So our customers generate revenue proportional to the amount of area they image. They sell data for about $3 to $5 per acre. But their cost structure is driven by the hourly pay of their pilots to fly the drones. And 80% of civil UAS operations are multi-rotor and only 20% are fixed wing. And these multi-rotor operations, they're only getting about 3 to 3.5 hours worth of data in an 8-hour workday, which is terrible utilization if you just look at that from a business model perspective. The problem we solve is we're going to produce an aircraft that allows them to lower their cost per acre by up to 45%, which is a huge margin for a services industry. And the reason for that is our aircraft can spend more time in the air taking data, less time on the ground swapping batteries, which leads to a much better utilization and a better profit margin for our customers.
How much more time in the air?
So our aircraft, let me first say, the battery-powered multi-rotors we're replacing can only fly 20 to 30 minutes while carrying a payload. And our aircraft will fly 2 to 3 hours while carrying the same payload.
That sounds like more than 45% savings.
Yeah, so there is the difference too, because you're spending time when it is on the ground. You got to pre-flight it, set it back up again. So just looking strictly ratio time of flight, it would be better than that, but you add in some other realistic constraints, it erodes it away a little bit. But we're still talking a 45% savings in the cost per acre, which is still massive.
Why did you start Advanced Aircraft Company?
Yeah, that's a great question. And when I was working for NASA, I had an opportunity to work on a very interesting project. And the goal was to see a conceptual design study. Is it possible to have an aircraft that can take off and land vertically, like what a helicopter could do, and yet fly for 24 hours? Two diametrically opposed requirement sets and something that's never been accomplished before in history. And I finished that conceptual design work, and I said, you know what? These requirements are feasible if we're willing to consider unconventional aircraft configurations, something that can switch from a hovering flight mode into a very aerodynamically efficient wing-borne flight mode. And this was actually a reimbursable job for NASA from an other government agency. And they said, oh, really? That's cool. Well, here's a bigger check. and build us a flying prototype and buy down the highest risk item of this technology, which was the transition between hovering flight and wing-borne flight and back again. So I did the conceptual design of the aircraft at NASA and led the project all the way through its flight testing phase. There's actually a cool video on YouTube made by the Public Affairs Office. You can search NASA Greased Lightning. And we finished that project. We flew it. You can watch the video on YouTube, and we showed that the technology was feasible. And then, like what NASA does at every project, we say whether it's feasible or not, put it up on a shelf, break up the team, and we all go work the next job. And I kind of thought to myself, I was like, wait a minute. Here I am working for NASA as a researcher, and I was kind of like pushing on a rope. And I was like, you know what? I just proved that this is a feasible technology, and I know there's great market potential for it. Why don't I quit my job as a civil servant and start a company? And so that's the story of why I founded Advanced Aircraft Company.
Bill, let's take a break now, and on the other side, let's talk about some new products, all right?
Okay.
All right, we'll be right back with Bill Fredericks, founder, CEO, Advanced Aircraft Company. You're listening to CEO Money. I'm Michael Yorba, your host. Segment brought to you by Alpine 4. Your host. Thanks for joining us. All right, my guest this segment is Bill Fredericks, founder and CEO of AdvancedAircraftCompany.com. All right, Bill, when we left off, we're just starting to get into some of the new products. Tell us about these new products that you're developing.
So our first product that we're developing is a long-endurance multirotor, and it can achieve a 2 to 3 hour time of flight compared to a 20 to 30 minute time of flight for an equivalently sized battery-powered multirotor because it has two unique technologies. The first one is a number of aerodynamic improvements to reduce the drag on the aircraft, and the other is a hybrid electric propulsion system in it. And this propulsion system conceptually is very similar to the Chevy Volt, like the car,
right.
Where there's a gas engine that turns an electrical generator producing electricity. In parallel are some small batteries, and then that provides the power source to run all the propellers on the drone. So those new technologies is what enable this big performance advantage in our first product.
Now, is this the Hercules you're talking about or the Greased Lightning?
That's correct. This is the Hercules.
Okay. What makes this so much different? Is it the amount of time, 3 hours versus, or 20 minutes versus 3 hours?
Yeah, that is okay. the prime differentiator in the market. And that longer flight time enables our customers to improve their utilization so their cost per acre could go down by 45% to acquire data.
Why is NASA interested in the Greased Lightning?
NASA was interested in the Greased Lightning from a technology demonstration perspective. So the larger role of NASA's research and why federal tax dollars fund the organization is to develop technologies to keep the U.S. aerospace industry ahead of other countries. And so this was just one of these neat technologies that would enable a new capabilities for small UAS. And so that was the reason NASA was interested.
Okay. You mentioned on the last segment. Now, by the way, before I get into the next subject, what about the lift, the ability to hold heavier weights? Are you working on that too?
No, there are other companies that are designing heavy lift multirotors,
right.
And they can carry much more weight, but they don't fly any longer. One thing that's interesting with battery technology is you try to put on more batteries to make it fly longer. The aircraft has to get bigger, and then you consume more power. And the net result is, as you make a battery-powered aircraft bigger, it doesn't actually fly any longer. You can carry your larger loads, but you can't fly any longer.
Okay, so there's a critical mass, a tipping point there.
Correct, yep.
Now, the value proposition. You mentioned that last segment. I wanted you to drill down in that because there's a value proposition for the client, the customer, but there's also a value proposition for the investor.
Correct, yeah. The value proposition for the investor is we'll be able to bring this product to market, and for the companies that start buying our product, they'll be able to underbid the other operators. So there'll be a market drive in the services industry to start buying longer endurance platforms. And then obviously if Advanced Aircraft Company can scale very quickly, we could capture a large percentage of that market segment, which then would allow an exit from consolidation to a larger aerospace company and a large payout to the investors in that exit.
Let's talk about scalability. You brought that up. Open that door for us.
Yeah, so scalability. So actually, I mentioned a little bit earlier that the purpose for starting the company was to commercialize the Grease Lightning. And in the business planning process, I realized I needed to pivot. And so the pivot is the Hercules aircraft first. So if the company went straight to doing Grease Lightning, we'd actually need to raise $6 to $8 million before we could make a penny of revenue by delivering these aircraft to the U.S. military. A difficult startup proposition. We've decided to pivot to the Hercules, which we don't need nearly as much startup capital, is one reason. And the second reason is Hercules I designed to be of an appropriate size, that it'll be the same propulsion system in both aircraft. So we can start generating revenue in the near term with a lower cost product. We can start getting some revenue through the company. Then we can raise the big money to go develop Grease Lightning on better investment terms, and we'll already have the propulsion system well at hand as we launch into developing the second product.
How much money are you looking for, and what is the use of funds?
We recently just closed an investment round, so it's nice I traded financial pressure for technical pressure, but our next round is probably going to be about a Series A size round, and with that round, we'll use it to scale the production rate of our first product, the Hercules, and then also use the rest of that round to develop Grease Lightning and to get that project running.
Okay. Do you see yourself as an international company, or you're looking for some kind of an acquisition prior to that?
At this point, the plan is probably maybe 5 to 7 years from now have an exit to a larger aerospace company. Having said that, though, there's nothing preventing international sales. We will have to work around the ITAR regulations, but that's paperwork to fill out with the State Department.
All right. Bill, we've reached the end of our segment here. I really thank you for being on the show, and contact information for our audience or our investors to reach out to you and participate.
Wonderful. The easiest way to get in touch is go to our website, contact us, advancedaircraftcompany.com, all spelled out.
All right. Perfect. You've been a great guest. Thank you, Bill.
Thank you. Have a great day.
You too. Bill Fredericks, founder, CEO, advancedaircraftcompany.com. It's Michael Yorba. You've been listening to CEO Money.